Okay, so in this lesson, we're going to talk about the difference between a linear equation and a linear inequality. It's very similar to what we talked about last week when we talked about the difference between equations and inequalities. This is just what if they're linear? We're comparing two variables now. How does that look on a graph and what's going on with it in terms of like the solutions and what it is? So just a little extension on that. We're going to run through this. Focused on what the solutions are. So just real quickly, we're going to look first at y equals 4x minus 1. That's graphed right here. That's this line. This is the line where y equals 4x minus 1. Um, any of the points on this line are solutions to this equation, and that's the whole point of it. That's why it's graphed that way. It's a representation of the solutions to this equation. So what is a solution? It's just any number that we can plug in for these variables that's going to give us a true statement on the outside. So I could take 2, 7, 1, 3, -1, -5, 1.355, and 4.419. Any of these things, I plug them in, they're going to work. So I'll show you real quick with 1, 3. This is x and y, of course. So that means y is 3, x is 1, and 4 times 1 is 4, minus 1 is 3, and you can see that 3 equals 3. Well, what if I were to pick one that wasn't on the line, say 0, 5, right? What do you think is going to happen? It's not a solution because it's not on the line. It's not going to work out. I'll show you real quick. 4 times 0 is 0, and 0 minus 1 is -1. 5 does not equal -1. So, of course, this does not work. This is not a solution because it's not on the line. We could have predicted that. All right, so that's pretty straightforward. How does it get different when we have an inequality instead? Okay, so I've put in y is less than 4x minus 1 here. Let's turn off the equation and turn on the inequality. What's different? Well, two things. One, this is no longer a solid line, and two, this is a shaded area. We got a shaded area and we have a dotted line. Okay, what does that mean? All that means with the dotted line is that we're no longer allowed to have these things be equal to each other, right? We've got an inequality now. Y is less than 4x minus 1. It's not allowed to be equal. Less than. So let's say I were to take 1, 3 again, right? The point 1, 3 is right here on the line. We know that that's going to be equal to, right? Is 3 less than 3? No. This is not a solution anymore. This line is no longer a solution. And to show that, we have to do a dotted line instead of a solid line, right? Well, what if I were to change this back to if I were to change this to a less than or equal to, what do you think will happen? Boom, solid line, right? Because now we're allowed to be equal to. Is 3 less than or equal to 3? Yes, because it's equal, right? Is 3 less than or equal to 3? Yes, because it is equal. It's not less than, but it is equal. So it's allowed. So solid line again, right? But if I take that away, if I make it a strict inequality and say it has to be less than, we're not allowed to have that on the line there. Okay, the other thing that's interesting is we've got this shaded area, right? What do we think the shaded area is? That's actually all of the solutions. So it used to be with the equation, we just had, here's the solutions on this line. With this inequality, we've got this whole area of solutions. So let's check, see what we mean. We got a point here for 0. Let's plug that in for x and y. That means y is 0, and x is 4. So 4 times 4 is 16, and 16 minus 1 is 15. Is 0 less than 15? Yes. So really anything over here is going to give you where the y is less than that, right? So this number will be less than that number. So we've got a whole shaded area over here. Well, what if we try one that doesn't work, or that's not in the solution area over here, like let's say 0, 5, right? That would mean that y is 5 and x is 0. And we already did this one. 0, 5. So we know 4 times 0 is 0, minus 1 is -1. Is 5 less than -1? No, 5 is not less than -1. And we could have guessed that because it's not in the solution area, right? It's not in the shaded area. So how do we know which side to shade on when we're doing this? It's specifically this. It's saying y is less than this. So y is our vertical axis, right? X is the horizontal, y is the vertical. So we go to here's where it's equal, right? Here's where it's equal because we know that's the line. So this is where it touches the y-axis. And where is y less? Y is less when you go down. It's greater when you go up. It's less when you go down. So when this says y is less than this, it would be beneath it. If I were to change this guy over here to greater than, you can probably guess what's going to happen. It's going to be up above instead, right? Up above instead of below, because this is saying less than, so we're talking beneath it on the vertical axis. These are lesser numbers and these are greater numbers. So two things that are different when you're talking an inequality, linear inequality on a graph. One is you can either have a dotted or solid line. That just depends on is what's on the line what's equal to allowed to be part of the solution. And then we also have a shaded area. So where does it fall? Is it less than or greater than? And where are solutions? That's our solutions fall in the shaded area.